Okay, let's have a look at this one here. Okay. 2, -1 and 1, 1 are points on a circle, and x plus 3y plus 1 equals 0 is the equation of the tangent of the circle at 2, -1. And the equation of S1. Okay. A quick sketch wouldn't harm. So 2, -1, that's a point on the circle, as is 1, 1. And then also interestingly at 2, -1 we have the tangent, and the tangent is, I could rewrite that as y equals -1 over 3x minus 1 over 3. So it's downward sloping, so it's going to be something like that. And so if that's a tangent, our circle, might be something like this. The slope, this perpendicular line, is 3. And this is the point 2, -1. So we need to move up so that the distance here and here is equal. Okay, so this line could be represented as 2 plus, you move 1 unit to the right and you go up 3 units. And then this point here is 1, 1. So we need the distance from there to there to be same as the distance from there to there, that point. Okay, so that will be 1 plus t squared, this minus this, plus -2 plus 3t squared. That should equal t squared plus 9t squared. So we get 1 plus 2t plus t squared plus 4 minus 12t plus 9t squared equals t squared plus 9t. It's nice that it's not quadratic because that cancels. And that cancels. So taking the t's to the right, 12t minus 2t is 10t. 4 plus 1 is 5. So t is a half. So the point is 2.5. And then -1 plus 3.5. So that's a half, isn't it? Okay, so that's where this point is. And the radius would be the square root of 5 over 2 minus 1, which is 3 over 2 squared, plus 1 over 2 minus 1 is minus a half, squared is a quarter. So that's root 10 over 4. So the circle is going to be x minus 5 over 2 squared plus y minus a half squared equals 10 over 4. Is there any way I can check this? Indeed there is. If I take out my calculator, I can make sure those 2 points that we know are on the circle work as we sub them in. So 1 squared plus squared minus 10 over 4, so I should get 0. So 1 minus 5 over 2 squared plus 1 minus a half. That checks out. And then the other point is 2 and -1. That checks out. So those 2 points are definitely on the circle. So, I mean, it doesn't conclusively prove it's the right circle because we'd want to make sure that it's a tangent here. I mean, check the slope of the tangent, but it's all looking pretty positive, so we're probably okay. S2 is that circle, and L contains those 2 points, and prove that S2 is the image of S1 under axial symmetry of the plane. So I'm going to need, I might even have to expand that, but okay, let me just make a little bit of space. Okay, let's just pop that over here. X minus 5/2 squared plus y minus 1/2 squared equals 10/4. Okay, so we've got our circle. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 2.5. Okay, so that's the center. Radius is about 1.5 units. That's about a half, so it's not going to be a very big circle. So something like there. And S2 is this circle. I should complete the square. So that's S1. S2 is x minus 1/2 squared plus y plus 1/2 squared. So that's x squared minus x plus y squared plus y equals 2 plus 1/4 plus 1/4. That's 5/2. Okay, that's S2, and that will be at 1/2 minus 1/2 and a little bit bigger. Is it? Actually, no, actually it's a, oh, I wrote 10/2. I didn't cop that I could simplify that. That's embarrassing. 5/2. I wrote 10/4. I should have written 5/2. Yeah, it's the same radii, which is good. So I guess they might nearly be touching. Okay, and there's a line from 2 minus 1 to what 1, 1. Yeah, so there's some line here, and we have to show. So it's good that they're the same radii. We have to prove that S2 is the image of S1 under axial symmetry of the plane in L. Write down the equation of a circle which is invariant under the transformation. Okay, so they're the same radii already, so they already have the same radii. So therefore, we need to show the distance is equal, that the distance from here to here equals distance from there to there. So let's calculate the distance, perpendicular distance, d1. We'll have to get the equation of the line. All right. Y equals m, That's going to be 1 minus minus 1, which is 2. 2 over minus 1. So minus 2 x plus c. So when x is 1, y should be 1. So I think it's plus 3, I think. Let's just double check that. The slope 1, that's 2 over minus 1. Yeah, and when x is 1, minus 2 plus 3 is 1. Yeah, it looks okay. Or in other words, 2x plus y minus 3 equals 0. So the distance would be 5 over 2 times 2 plus 1 over 2 times 1 minus 3 all over the square root of 5. Let's see what that is. But that's nice, they cancel. So it's 5 minus 3 plus a half divided by root 5. So that's root 5 over 2. And then the second distance would be a half times 5 over 2 minus a half times 1 minus 3 all over root 5. So again, they cancel. No, must have made a mistake. I wrote a half. And I cancel. Oh, sorry. It's 2. 2 times a half. No, 5 over 2 there. It's a half, and it's in that form. 2 times a half plus minus a half. Yeah, okay, let's try again. That's 1 minus a half minus 3 modulus, and then divided by root 5. Yep. That's also root 5 over 2. Yes. So we've proven that these distances are equal and it's perpendicular, and the radius here and the radius here are the same. So I think that should be enough. And the last thing to do is an equation of a circle which is invariant. So I guess really any circle that has its center on this line, like maybe here, which would have to be the midpoint. So we could go with the circle, which is the midpoint. So the midpoint of minus 5 over 2 and minus a half is minus 3 over 2. And then for the y, that would be 0, won't it? Between minus a half and a half. And it doesn't really matter what the radius is, 1. So I've just put a unit circle right there. Yeah, okay. Yeah, okay. I think we've gotten everything here. S1 is that. Prove that S2 is the image S1 under axial symmetry of the plane in L. Write down the equation of a circle which is invariant under the transformation. Yeah, the one right in the middle, radius 1, should do it. Yeah, I guess there's infinitely many, but that should be I think the one that perhaps they were thinking of in particular. Okay, not too bad of a question actually. Thought it'd be much worse. Yes, usual amount of time as well. Okay, fine.